Lavanya, you can explain module to module. Design a test bench. Jaideep, you can observe whatever is she explaining.
Okay, sir.
Tomorrow I will explain the synchronous FIFO. Is there any doubt? Ask tomorrow memory regarding FIFO, I will explain. Clearing doubts offline student, right?
Hey Jayati, you can hear me?
Yeah.
Okay, I'll explain very simply, okay? If you have any other doubt, like you can just ask. Okay, so this is like the memory design. You can see it?
Yeah.
So you explain in paint what is memory, what is the signals. Don't directly explain code.
Sir?
Explain memory, what is the input signal, output signal. Based on that, you can explain design and test bench.
Okay, like in paint you want me to explain, sir? So what I was trying to say is that there will so there will be inputs, right?
Okay.
So this is like the memory. Okay, this block represents memory. And so the bits that you are going to enter from here to here will be width. Okay.
Okay.
Width. And this entire space will be there, right? This would be the depth. Okay.
Okay.
So okay. So now we will assume that whatever you take, the width is any bit. Okay, it can be any number of bits. So we'll take it like 16, 5, whatever. So we're taking it 16, and here we are taking it as 32. Okay, the depth is 32. Okay, then there will be something called as width of the address. Okay. Okay, so what would this be? So we will calculate this using the depth. Okay, so now if depth is 32, how many bits are required to represent 32 in the terms of 2 to the power? Do
To
you
the
understand
5.
what I'm asking, David?
5. Yeah.
Yeah, yes. So 5. So width address would be 5. Similarly, it's like 64.
6. 2 over 6.
Yeah, 64 is 6. Okay. To get this directly, we have a system task called as dollar to log. Okay, and then whatever we want the bits for. Okay, so we want it for depth, right? So we'll put right depth there. That's it. Then directly we'll get the value of 5 or 6 or whatever, depending on the depth there we are giving.
Okay. Okay. Understood.
Okay? Understood. Now, so for this memory block, what would be the inputs? What would be the outputs? So we'll first like go with the inputs. Okay. So what do you want input? First would be clock, right? We want a clock.
Yeah.
Okay. Then we want a reset. Okay.
Okay.
Then what do you want? We want something to enable it, enable reading or writing, right? So we will write it as WR slash reading. Okay.
Okay.
And then we will write the data, right? We'll write it into the memory. Okay.
Okay.
And then to write it, we need something called as valid, right? Only when valid is true, we could write it after setting the reset. Okay, so valid. Now, you remember that handshaking thing we have with mechanism?
Yeah. Yeah. There are two signal use invalid or
Yeah.
ready.
So after valid is true, if when ready is there only, we could read the data
Okay.
or write the data. Okay, both of them should be true. Only then, because so God, sorry. Yeah. So here we will read the data from the memory. We will read the data. So what I'm trying to say is, so hand checking mechanism will work only when both the side is enabled. Like this is the monitor and this is the pen drive means if both of them are true only, you can read or write the data. Okay.
Okay.
So this is the
It
basic
means
thing.
both are true, है ना? Valid or ready.
Ready. Yeah, both this and this will be true. Okay.
Okay.
Only when two components are ready to interact with each other, we can read the or write the data. Okay.
Okay.
It depends on what the enable pill is saying for which the writing will happen or reading will happen. Okay. You understood the basic.
Yeah. Yeah.
When you
I
see the code,
understood.
you'll understand.
Yeah. Yeah. I understood.
Okay. So now let's go for the code. Okay. So here we are taking three parameters as I explained: width, depth, and address width
Okay.
or width of the address. You can take it whatever. Okay. So you understood till third line, right?
Yeah.
These three lines you understood, right?
Yeah. Yeah.
Okay. Now as I explained the inputs. So in the inputs, as you can see, right?
Oh yeah. Okay.
And then the valid also will be 1 bit. Similarly, ready also will be 1 bit. you can analyze it, right? You're understanding what I'm trying to say?
Okay, if the valid is equals to 1, na, you say.
No, no, they're all one bit, like the reg, they're only
Okay,
one bit. You don't need to
okay.
take a vector.
Okay, okay. You take one bit in the input side. All.
Yeah, yeah. So whatever, see here, I would have given it as, so width here is 16, right? So is to 15 is to 0. That would be the vector of write data.
Right data. Okay.
So reading also will happen in that same space. You can't like read it from some other space, right?
Okay.
Yeah. So as you can see here, I have declared the same thing that I've explained. Okay, so input, I have clock, reset, valid, and read, like read, write, enable is one. It's just one bit, so there is no vector here. Okay,
Okay.
okay, and then we have like okay. There's also one more address. We need address, right? Without address, how would we locate it? So there's one more input. And that's the address. You have to give the address from which you're reading or writing, right? That's the input, okay?
Okay, okay.
Yeah. So there are like 1, 2, 3, 4, 5, 6 inputs and 2 outputs, okay?
Okay.
And in the 6 inputs, 2 inputs will be like vector and all the others will be reg, like in single bit.
Okay. Malad, two inputs, you take the vector and other also is raised.
Yeah. So here as you can see,
Okay.
there will be like there are 6 inputs, so out of which 4 of them are single bit, okay, and we want to give the address, right? To give the address, we are using address width here, this parameter, to 0.
Okay, okay. Okay.
Okay, that's how we can access the address. Similarly, for writing the data, I already told the data that will be written will be a 32 bit. In this program, I've taken it as 32 bits. You can take it as anything. Okay. So I'm saying that width to 0, width minus 1 to 0. Okay.
Okay.
And then the output would be like from whatever input you're given, where you have written the data, from there I'm taking the reading the data. Okay, so the vector size would be same. Okay,
Okay,
and
okay.
then last last is that ready. For handshake we need output, right? Ready will be an output.
Okay.
Okay,
Understood.
and
Till.
then we are giving an like internal wire. Okay, this entire line is an internal wire. Okay, this 11th line. So we
Oh.
are declaring a memory which is having an element of 16 bits, like 32 bits, and a depth of 64 bits.
Okay.
Okay, yeah, this is an internal thing. You don't need to declare it in the input and outputs. This is internal, but it is important. Okay, because this is the memory space in which we are storing all the data.
Okay.
Okay, now the logic is like this. Okay, you are basically, because we are using an array here, we need I. Okay, this you understood, right? 12th line, we are declaring this as I because we are using an array. This is an array, right? To
Oh.
access any array, we need to use for. Okay, so for declaring for, we need any like this I. Okay.
In 11th line you declare the range. This is a matlab, it is a space of memory, na, what you declare the range width
There
minus.
is a space of memory. Yes, it's a space of memory that is internally we are at. The program is accessing. Okay, so
Okay.
it will have the width, the number of width that we have declared and the depth that we have declared. It's basically an coding representation of this block. This memory block, this entire block. If you write in codes, it will be like that. Got it?
Okay. Okay, got it.
This so basically this line represent that block. That's it. Okay.
Okay.
Okay. So now we are using always. Okay. So what I'm trying to say is at the positive edge of the clock, if the reset is 1, okay, then you have to give write data ready as 0, because these two are output, right? Read data and ready are outputs. So whenever reset is equal to 1, I'm saying that read data will be 0, ready also will be 0, and for every element of that memory, okay, this memory's array, every element will be 0. Got this much?
Again explaining this point.
Okay, fine. So um, so what I'm trying to say is, in this block, whenever a clock is positive edged, okay, and whenever reset is declared as 1, I want the outputs, which is ready, will be equal to 0. I'm declaring, it's just like flip-flops, 0, and this read data, which is also an output, to be 0. Okay, but this is not only for, this is like one input, right? One space. There are like 64 spaces inside this, right?
Okay, okay.
With
You
this
take
one
the one
input.
space.
Yeah. So for all of these memory spaces, I'm telling that it should be 0. Got it?
Okay, got it.
So that is why I'm coding it like this. Okay. So R data is 0, ready is 0, and for every memory block, okay, I'm telling that array value should be 0. All that 64 here I've declared here as 64, right? For all that 64 depth, I'm saying that in the memory it will be 0. Got it?
Okay, got it.
Okay. Now I'm saying that if reset is not equal to 1, that means reset is 0. Okay. Then you come for this else block. In else block, I will check that so in else block, I will check. So now what will happen here at this place? 1 minute. Yeah. So here the reset would be equal to 0. Okay. So when reset is equal to 0, it will come into this else block. Okay. So first thing I will check is if valid is 1. This is an input that I give. Okay. So when valid is 1, I say that the output would be ready output also should be 1.
Okay.
Okay. That so here valid is an input and ready is an output.
Output.
Okay. So I'm saying that valid is given as 1, you tell that ready is also 1. Basic. There's
Okay.
no problem here.
Okay,
Next,
okay.
we are checking one more condition in this if. Okay. There's one more condition which says that this is this read and write enable, right? So here I'm saying that if read and write is 1, this enable pin is 1, then in the memory address, Okay, write the data.
Okay. Why you take write or read in one sentence? Like,
You could take, I for easy accessing, I've taken it like that. You could also write two different blocks saying that read enable pill is 0 or 1, then write enable pill is 0 or 1. Then you can write two different blocks for writing the memory and not writing the memory, like that.
okay, okay,
You
okay,
understood?
understood. Okay,
So this is easier, like because in one pin itself, in one pin, one bit, it's either 1 or 0. So I am giving for 1. If it's true value, you write the data. If it is false value, you read the data.
okay,
Okay, so that's what this two lines represent. So what I'm trying to say is, if this enable pin is true, write the data in this memory block at this address.
okay,
Okay.
okay.
Or else if this is 0, okay, then
Read
read the
data,
data from this memory address.
memory
That's
address.
what I'm trying to say.
Okay, okay, understand.
Okay, so now you are clear with your
Yeah,
design. This is a design.
yeah, yeah. Clear.
Okay, it's a
Yeah,
very simple design.
yeah. Okay, I clear the point. Okay.
Okay, okay, fine. Now test bench is little bit tricky. Okay, we'll go with the test bench. Okay, so I will first teach you front end test bench, and then we'll see about the back end. Okay.
What is the meaning of front end, back end?
Okay. So in front end, the we are actually able to see an output wave,
Okay.
in the sense like this. These waves are there, right?
Yeah, yeah.
So you can see that. You can see the physical wave outputs, waveforms. Okay. But in the back end, we will not have it like that. It will directly write the data in files, separate files. You'll understand it when I explain. So you just go with the flow, okay?
Okay.
Okay. So now, as whatever you have given their inputs, you are just writing the same thing here. Okay. This much you understood, right?
Yeah, yeah, yeah.
Till this line, it's the same thing.
Yeah, till 11. Yeah, okay.
Okay. Whatever it's basically you're writing whatever module is there, you're just writing it here. That's it. Okay.
Okay.
Okay. So now, because you're using clock, we need to declare a clock. So that's what I declared here. Okay.
You move on 12th line. What do you written? 12th line.
I will come to that later. This is because we are using, because in this program I have given test cases, which is like forward write, forward read, backward write, backward read. So for that test cases, we need an vector. So like string vector. Okay. So I declared it like this.
Okay.
This is not necessary if you are not writing the test cases. Wait, I'll explain. So leave this for now. Okay, so till now, even without this, you could write it. I'll explain how you write it. Okay.
Okay.
Okay. So now, till here, 11th line is basically writing whatever you have written in your design. Okay. And then 15th line is in instantiation of that module. Okay.
Okay.
And then 18th to 21st line is just a declaration of clock.
Okay. Okay.
Done?
Done. 21 done. Okay.
Yeah. Okay. Now, so we are taking an initial begin. We are saying here reset is 1. So what will happen if reset is 1? This will happen, dude. If reset is 1, everything will become 0.
Okay. Read data. Okay. Everything is your. Okay.
Okay, that is only for the positive edge.
Okay. It's work only positive age, na?
Yeah, it works only for the positive edge. Okay, then it will remain the same. Okay, because here like 15 blocks means there will be like at 10, like at 5 there will be a positive, and again at 15 it will be a positive, right?
Okay.
Yeah. So at 10, at 5, all of this will be 0. Read data, ready data will be 0. Okay, I'll explain the graph afterwards. Okay, basically at 15, reset will become 0. Only then the logic will start. Yeah, this logic will start when reset is 0 at 15. Okay?
Okay.
Okay. So then I'll explain the logic of writing test bench. So what I'm saying is, yeah. So I'm writing a task function here. Without task also you could do it. So, should I explain separately for you? Do you want me to explain separately how to write it,
No, no.
or
You
if I explain?
no. You continue in this.
Okay, fine. I don't know whether it will get confusing for you. Okay. So what I'm trying to say is, this task is there, right? This task I'm writing in this particular task. I am writing it from one beginning bit, okay, and to the end bit. Okay, so I will declare like this. Okay, write from 10th bit of the array to 20th bit, like that. That's what I'm declaring here. Okay, beginning of the length and the ending of the length. You understood this much?
No.
Okay, fine. I understood. That's why I was telling it. I wanted to know whether. So till here you understood, right? This reset thing you understood, right?
Yeah, yeah. And in till 27 is I understood.
Okay. So I'll do one thing. Okay. 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 So what I will do is, I'll simply explain one thing. Okay. So I want to start writing, right? I want to start writing in the memory space. How do I start accessing memory space? I need a for bit, right?
Okay. If we
So I'll
if
write for writing. So till now, see, after writing reset, okay, if reset is 0, it doesn't matter. After that, I have to give an input saying that valid is 1, then ready should become 0. Then I have to enable read or write, and then only my reading or writing will happen, right? From the logic. After understanding the logic, till here we have come. But we need valid, we need ready, we need read or write, and then we have to, whether you have to write the data or read the data, all of this is there, right?
yeah, okay.
Okay. So what I do is I write a for loop.
For access the right
Okay.
data, na?
For accessing.
Okay.
Okay. So first I write here mm, for I equal to 0, comma I I less than depth. Uh, so like this depth is this depth. Okay, fine. And then um, I equal to I plus 1. Okay, so this is how I'm going to access the array. Okay, for that, at all the positive edge, cos edge, of the block. Okay, I am accessing the address ADR is equal to I. This much you understood?
Yeah, okay. Understood.
Okay. So this is how I will access the address. For accessing the address, I need this.
Okay, that is only for address, no?
Yeah, this is how I access the address.
Okay.
Okay. Then after accessing the address, I say that uh, write data will be write data is equal to random. Okay. You're simply writing some data randomly. Okay, write some data, but all this data should be 16 bits, like 32 bits, because we have declared it like that. The width of the data will be 32 bits. Got it?
Okay.
Okay. Yes. Now, now, then we are enabling the pin. Okay. When does read and write happen? When the enable is given as 1,
One.
and valid also should be
One.
1. Okay. Okay. And
Okay.
lastly, we are waiting for the ready to become uh, 0, because after you give valid is 1, it will not auto, it will take some time for it to become ready to become 0, right? It is like an implication, right? Only when valid is 1, the ready will become 1, like that we have given, but it will take some time. Internally it will take some time for it to become. Okay,
Okay.
you understood what's happening in this block?
Uh, in 34, you take a weight ready is goes to 1. Why?
Because, and that's what I'm telling. See, I when valid becomes 1, okay, ready, I have declared that the output ready should become 1.
Okay.
So it is internally happening. I have to wait till that ready is becoming 1. Only then my read data is 1 or not, I have to check.
Okay.
That is why I'm waiting. You got it now?
Yeah, yeah, yeah. It's for waiting signal,
So
na?
yeah. So you understood this entire logic I explained now.
Yeah, yeah. Okay. Understood.
Okay. So this is how writing happens. This is a logic for writing.
Okay.
Okay. Similarly, for reading, this is, I told you, this for is for accessing the address.
Address and
Where we are, yeah. Okay, address. And we know that the enable read and write should be 0 for reading the data,
Reading the data. Okay.
and this is handshake mechanism.
Yeah. Okay. Okay. Understood.
Handshake mechanism should both be 1. Only then we'll check whether read and write is 0, and then reading will happen. That's it.
Okay.
That's it. Okay, so this is the logic. Now, why we are writing the task? That is the most important. Okay, in the task we have given input as address width BL, address width EL. Okay, so what happens is I'm saying that I'm randomly taking an input. Okay, so like this I will write. I'm using task, right? So I will write it like this. So what I'm trying to say is, in the what this line is saying is, so I have a block of memory. So I'm saying that from 10th line only, 10th address line. Okay, 10th, like this 10 lines will be there, right? This is the 10th line. From the 10th line, the address will start and it will go till 20. Okay, so I want you to randomly read and write only in this memory space. You understood now?
You again explaining?
Okay, so what I'm trying to say is, here the task that I've given, okay, task logic you understood.
Yeah.
Now I'm saying that task, write, input, BL. BL means beginning of the length and EL is ending of the
Okay.
length. I have declared it like that.
Okay.
What does BL and EL represent is, it would be this beginning and the ending from where in the memory I want you to write. This is the address, okay, memory. I have declared that memory has 64 depth, 64 bits depth, right?
Okay.
Okay, that means what will happen, there will be 64 lines inside this. Got it?
Got it.
Okay, now when I say BL, that will be beginning of the length. That means from where I want you to start writing in the memory. That means if I tell BL is 10, it will start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
10.
From the 10th line, it will start writing. That 10th line only I'll start accessing the address. Okay.
Okay.
Then EL is the end of the line. Okay, EL is the end line. That I've given as 20. Okay, so so I'll be accessing from 0, then 11, 12, 12, 13, 14, 15, 16, 17, 18, 19, 20. Till 20th line, I will be able to access the address.
Okay.
Got it?
Got it.
So that is what I'm trying to declare. I am telling from which width of which bit of the width I will be able to access for the address. That is what this ELBL represents. You're understanding now?
Yeah. Okay. Okay.
So I'm saying that for the task function, when I'm writing task right, the input that I'm giving will be the beginning of the length and the ending of the length.
Length.
Okay,
Okay.
you got it?
Got it.
Now when I wrote, so see here, when I wrote the function, I wrote it as 0 to depth. So from what bit to what bit it is accessing?
Beginning starting from 0 until ending 31.
Yeah, 64.
Okay. 64.
It's depth, right? Depth I've declared as 64.
Okay.
So it will access till 64 bits.
Yeah. Yeah.
Okay.
Okay. 64.
Yeah. But here what I've given?
Is starting from beginning. Okay.
Beginning and ending.
Ending.
Okay, so in the example that I've taken as 10 and 20. So what would be the BL?
BL is 10.
Yeah, EL is,
EL is 20.
so till what to what it will access?
After 10, he accessing.
Yeah, from 10, not after 10, because we have given
Okay.
equal to, right?
Okay. 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 Okay.
From 10 less than 20, not 20, less than 20.
Less
That's
than
it.
20. Okay.
Okay, so this entire coding is the front end.
Front end. Okay.
You understood now? This is the basic idea.
Yeah. Understood.
Okay. Now, what will happen is, um, back end, what will happen is, this is the back end. Okay. Here also we will give BL and EL because we want to know from what address to what address length we are accessing the address, like say memory, right?
Again, tell what told.
See, whenever we are we are
Okay.
writing in this task BL and EL. Okay.
Yeah.
This is given to know from which uh, bit of the memory I want to access.
Yeah. Okay.
This much you know. Okay.
Yeah.
Now, this read memory dot h is a system task.
Yeah. System task.
Okay. Okay. And what does this do is, I'm telling there is a demo dot text is a file.
Okay.
Okay. In this demo dot text, I want you to read every data
Okay. From demo.text.
and store and write, yeah, and then store that data in memory.
Memory. Okay.
That's what I've written in this line. You understood now?
Yeah.
It's a little bit confusing, but I'll explain again. So whenever I'm telling write, backward write, that means I want to write some data into the
Memory.
file.
Okay. File.
Memory, yes, write some data into the memory. But here I'm not directly giving the data. Okay, I'm not directly giving the data like here, random data. I'm not
Okay.
giving it like that. I'm
Okay.
saying that
Specific
you go
data.
to a file called demo.txt.
Yeah. You give the specific data like demo.text na in this back.
Yeah, in demo.txt, read all the data that's given in that and store it in memory.
Story in
That is
memory.
what I'm trying to tell in this slide.
Okay.
You understood it?
Understood.
Similarly, after storing, I want to read, right?
Yeah.
Okay. So what I do is, for reading it, I can't, internally it will may store in memory, but I don't know how to read it, right? So I'm telling that whatever you have read, right, you write that in this separate file called as copy.txt.
Copy.text. Yeah. Okay.
Yeah. So so what I'm trying to tell is, in backward write, you'll write read dot memory dot h. H here represents hexadecimal. You can write binary, you can write octal, you can write whatever. Read uh, read mem is the task. H is because I want it in hexadecimal. You can write it in binary or whatever. You can write B, C, whatever you want to write. B for octal, O for say B for binary, O for octal, like that. Okay,
Okay.
and then I will write dollar right. In this particular, what will happen is, after reading it to the after writing all this data that I have in demo in the memory, I want I want to read that data, but I can't directly access the memory which is inside the computer. So that I tell that you write whatever you have read from that demo.txt, write that data in copy.txt. That is what I'm reading.
Okay.
Got it?
Okay.
That's it. This reading from a file and writing to a file is called as backend, because
Back.
it's happening internally. I'm not doing anything.
Okay.
That's all. You understood the difference between front end and back end now?
Yeah, yeah, understood. In 16 line,
So front end means we are giving,
you told us in
yeah,
16
yeah.
line, 69 line, in read the memory data. Whatever data you given, if any specific data, yeah, if any put whatever we put in the data, if we want. You, like
Yeah,
you give
in
any random
demo,
also data, na? You will like other data. You take also other data, na?
I didn't get it. This one.
Yeah, yeah. In this line.
Yeah, yeah. You see, so what will happen is, wait a minute. So I will like this. See, demo dot. Yeah, this one is there, right? This is a text file.
Okay.
I have created a demo dot thing. Okay, I'll create it. Oh, okay. I don't need all of that. I must simply wait 1 minute. I'll do one more thing. Just so this is so in this file, I like because I've given 64 bits. For 64 lines, I can write any number of inputs. Okay.
Okay.
Wait a minute. Escape input. E 1 2 3 enter. And the length of the bit can be 16 bits. I'm just taking 4 bits. Okay, I can give it for 16, whatever you want. Okay, so like that will try next. Okay, like that you can keep copying, pasting it. Okay. Okay.
Okay.
Till 26 I've written. Okay, like this, let it be. Okay, this is like I've saved this one. This is my demo.txt. Okay. Now in that file, now what will happen is when I'm telling read or write, it will read from whatever address length that I have told. Okay, I can tell from because I've written from 0 to 26. I can read any write like I can read any data from 0 to 26 and store it in this memory. That will happen in the back, right? And for reading also, I have to give the space only from what I have declared.
Okay.
Understood?
Okay. Okay.
Okay. So this is the basic idea of back end read and back end write. The logics you understood, right?
Yeah.
Now, so these are the logics. Okay.
Okay.
Now, now I will explain to you what this. So you don't need task also. Like if you want to just read and write, you want to just see how memory works. Okay, you don't want this task and all. You can just write these for loops inside here. Just after this reset thing, just write it inside here and just run it. It will run.
Okay.
Simple memory.
Okay.
Okay, but I want to access it as a task. I want to tell them from which depth to which, like which place to which place I want to access the address. For
Okay.
that only we are writing the task.
Okay. If we want directly only access the file, if but only logic put in this line, na?
Yeah, you can just directly write, like directly simply write for from whichever length to whichever depth you want. You write
Okay.
it there and write the logics and simply run it. This is for writing the data. For reading the data, same way you will write this logic. This logic you write and run.
Okay. Okay.
Okay.
Okay.
Now I'll come to this point. You asked me why we are writing, right? This is not enough. Yeah. So why this test case is coming,
Yeah.
right? Okay. Now I'll tell you why it is coming. So now we know we know four different types of things. One is forward write, forward read, backward write, and backward read. Correct?
Okay.
Back end for front end reading, front end writing, back end reading, back end writing.
Back end
Correct?
writing. Yeah. Okay.
This is back end writing here. Okay. This is back end reading. This is like front end writing, and this is front
Front
end
end
reading.
reading. Okay.
Okay. You know now this much you know.
Yeah. Okay.
Okay. Then so what will happen is so when they ask you what are the test cases that are used in memory, there are four test cases. Okay. One is simple for front end writing and front end reading.
Okay. First, we
Okay.
only if we take the front end writing and front end reading. Okay.
Okay. Then is back end writing, back end reading.
Okay.
Other one would be front end writing and back end reading.
Okay.
Back end writing and front end reading.
Okay. Inside this, what he write on like b backend write underscore zero depth divided by 3.
This one.
Yeah. 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 In upper.
So I'm declaring the address till which I want you to access.
Okay.
From
Okay.
0 till
Okay.
depth of 3 means depth is 64. 64 divided by 3. That much only you have to access the address like that
Okay.
only.
It is a desired. It is a desired address, na?
Yeah, I desired as an I want.
Okay. Okay.
Okay. And then there's one more test case that is like random location. Okay, I'm giving like random whichever location I want, and this is like I have written for front and right and front and read. Basically it's in random.
Okay.
location.
What is the logic behind like you take the in random logic write 10 comma 20? What the logic behind is 10 comma 20?
Because I know the exact address location,
Okay.
and
Okay.
basically this also can be done here. Okay, it's not like separately you're doing, but here I'm using in terms of depth. I don't care what I could just go to parameter and change the depth.
Okay.
Okay,
Okay. Okay.
but here what will happen is
Huh.
I'm saying that I want it from this place to this place like.
Okay. Location is given, na? Okay. Not given. Because if we write in test bench like write 10 and 10 comma 20, this is given, it is not given. Like if we how we know 10 comma 20, this is a location of
Oh,
how.
that is because I specifically want it from 10 to 20.
Okay. 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 Okay.
I am giving as a user, I'm giving it from 10 to 20.
Yeah. 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 Okay. 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 If the user it is know na how which address location is access. Okay. Okay.
Yeah, when the user knows that he wants to access this and this location, he's using this test
Okay.
case.
Okay. Understood.
You could give anything like 1 to 0, whatever you want. Okay.
Okay.
But basic idea is that from which point I'm writing, from which point to which point I'm writing in the address. Okay. From there only I can read or read, right? If there is nothing to, if I've not written anything in that address space, how could I read from there?
Yeah.
Okay, so that is why I had put here 0 to see how it works. Like if 0 and 10 is given, that means the only common point is 10. Only the address, not even 10, because 10 means it will be less than, I would be able to access only till 9 here, right? Because less than EL I've given here. That means from 0 till less than 10. That means 9. Till 9 o'clock only I'll be able to access. There is no common point between these two things.
Okay.
I'll not be able to read anything. You're understanding what I'm trying to say?
Okay. Okay. Understood.
Okay. So, yeah. So, now what will happen is I am declaring as argument called test case, and I'm giving the test case width to be 30 into 8.0. You can give any vector length that you want. Okay, I am giving it as 30 into 8.0 because I'm taking it as a string. Okay,
Okay.
this forward, this can be anything, right? I can name the test case as anything. I can write it as something like, yeah. So this forward thing, I could write something like this also. It's my wish. Understood?
Okay.
This I have declared this length to be 30 into 8.0. Okay. It can be any length. I can just simply give like 8 into 0.
Okay. It's not necessary
But
30.
huh?
It is not necessary to take the 30 into 8. Whatever
Yeah,
we
I
want.
felt like because I'm using word, I'm using letters. Before and all, we used to use binary numbers, right?
Yeah. Okay.
In cases, we used to write binary numbers, like for that multiplexer. We used to give that cases where we used to write if the sequence SEL is 10001, like that we used to give, right?
Yeah. Okay.
So basically, because I've taken a string here, I'm just like giving a larger space. That's
Oh.
it. It's just my comfort.
Okay. Okay. Understood.
Okay, so I just declared a test case, which is a vector which has a space of this many bits. Okay,
Okay.
and then you know how value plus arg works, right?
Yeah. 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 I know dollar value and dollar plus
Yeah.
argument.
So basically, I'm saying that the user will give me what kind of an operation it wants. Do they want front end only? Do they want back end only? Or they want random? They will give it to me.
Okay.
Done?
Done. Okay, when I asked the question, one thing, that all the cases happen in one time, that is going to like
No, because the case, because you're using case, whatever case that we are declaring in the run to file will happen.
okay,
So here, what I will declare random location.
okay, okay, okay,
I will declare the test case random log. Okay.
okay,
So random location will have. That's it. That's the basic idea of test bench. All of this is there in once you run the program. If you have any doubt, you tell.
okay. I understood, na, in the test bench also understood.
Yeah, that's what I'm telling you. Go to Chetan sir's thing. He also has the same program. You go, you check it out, and then if you have any doubt, you just tell me. I will.
Okay,
Just try that.
you explain one more thing, no? Waveform. How will we understood by the waveform also?
Waveform and see whether it is running. I don't know whether it's running or not. I was doing FIFO. Like I'm not in that file. FIFO. Quit. Quit. Sim. So I've given address location to be, sorry, wait. I'll explain one thing. Yeah. So what I've given, yeah, I've given test case to be random location. So what does random location do? It says that from 10 to 20. I'll make it a little bit more simpler. Wait, first I will show you how everything works. Then we go for separate case. 10, 20. Okay. So this, let's take this thing. Then here. Yeah. Hopefully it works properly. To make the screen bigger. How do you make the screen bigger, dude?
Okay.
Okay, let's start. Uh, yeah, so I'm saying that from the address. So I've said that from the address 10 to 20, that means from 10 till 19, that means 9 address के लिए I want to write, and then from that address only I want to read whatever is the data. Okay. So I'm starting like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, from the 10th bit till 9, there will be 10 bits. So for that, I've taken in the write data. What will happen is randomly it is given some data. How do I go back now? Yeah. Yes. So you understood this?
No. No.
Okay. Dude, after 0A means what in hexadecimal?
It is a 11, no?
10.
Okay, 10. Yes, yes, sir. Okay, 10. 10, 11.
So
Okay.
from 10th bit, it is randomly writing some data.
Yeah. Okay.
From like that, 10 to 19, it is writing. That's it. Some
Okay.
data it has written.
Yeah, yeah, yeah. Okay, okay, okay. Got it.
After writing, I've given one clockwise 0, and then again I'm telling whatever you have written, you read the data here. You're seeing it?
Yeah. Okay,
Wait,
okay.
I'll show you.
After.
I'll show you more clearly. Wait. See, here what am I first reading? 1, 2, 1, 5, 3, 5, 2, 4. Where is it I'm reading? I'm reading it from the 10th space.
Yeah.
Okay. Sorry, I never use this waveform so much. Okay, that's why I'm having so much difficulty. This is where am I reading it from? So whatever I've written in 10th space, I'm reading that only here. 1, 2, 1, 5, 3, 2, 4. That only I'm reading.
Okay, I got it. I got it. After the 10th space,
Yeah.
you in the 11th. Okay, 11th address location. Okay.
It's the same thing. I'm reading the address location that I'm accessing for read and write is the same address location. You can see it here. Wait one. 0A, 0A, 0B,
Okay.
0B, 0C. You're understanding? I'm accessing the same thing.
Yeah. Okay. Okay.
That's it. Now you understood?
Yeah. Okay.
Until you experiment it with yourself, you will not able to understand it. You write the program, you again you do this, then you will understand. It's very simple.
Okay. Okay. Thank you, Lavanya.